Okay, Assalamualaikum. So we proceed to the next topic, which is the transformation. Okay, if you can remember, the transformation will be conducted if one of the assumption for the residual is not fulfilled. Okay, assumption of regression analysis, which is what is the assumption for the regression analysis, which is the linearity, the normality, dan juga constancy of the variance. If one of these assumption is not fulfilled, so we need to do the transformation in order to use the data ataupun to use the regression function that we have. Okay, kena buat sikit dulu transformation, whether on X variable or on Y variable ataupun both, for both variable. Okay, the simple transformation of either the response variable Y or the predictor variable X or both. Okay, so let's see if there is a non-linear relation exists in the dataset. So what we need to do is, okay, we consider the transformation for linearizing a non-linear regression relation when the distribution of the error term is reasonably close to a normal distribution and the error term have approximately constant variance. If the non-linear relation is not if linearity is not fulfilled, the assumption of the linearity is not fulfilled, only linear assumption is not fulfilled, normality fulfilled, constant variance pun fulfilled. Okay, homoscedasticity fulfilled, normality fulfilled, only linearity saja yang tak fulfill the assumption. So what we need to do is we do the transformation on X. Okay, should be a 10. Okay, so we can do the transformation on X sahaja. Okay, on X sahaja if non-linear relation happen in the dataset. So macam mana nak check for the linearity? Sama ada you check gunakan scatter diagram of Y versus X kan. So kalau you tak nampak any linear trend, sama ada increasing or decreasing. Kalau ada nampak cubic ke, ada nampak quadratic pattern ke, so that mean the linearity assumption is not fulfilled. Ataupun boleh juga kita check for the linearity, we use the scatter plot of the residual versus X, betul tak? Okay, boleh juga kita check untuk linearity, which is if the residual, if the scatter plot of residual versus X showing that there is any pattern. Okay, sama ada megaphone pattern, quadratic pattern, okay, any pattern yang ada yang timbul if we create the scatter plot of the residual versus predicted or residual versus X. So we can say that the linearity is not fulfilled. Linearity assumption is not fulfilled. Ataupun boleh juga kita check gunakan test the lack of fit. Kan? Okay, so now let's say linearity is not fulfilled. Linearity assumption is not fulfilled. So we need to transform the X. So macam mana cara nak transform X tu? Okay, ini contohnya. Okay, if the scatter plot shows the pattern, this pattern, okay, pattern A ni, so we should do the transformation for X, which is sama ada square root kan the X value or the X observation ataupun jadikan dia sebagai log X. Okay, kalau the pattern of the graph of ataupun the plot of scatter plot Y versus X showing this pattern like B here, so we should transform X kepada X square dan juga exponential X. If the pattern is like C in C diagram here, we should transform X as 1 over X ataupun exponential of negative X. So you need to know each of these transformation for X according to its pattern here. Okay, so let's see the example. Okay, data from an experiment on the effect of number of days of training received on the performance in a battery simulated sales situation represented in the table 3.7 here. So we have data Y dan juga we have data X here. Okay, a scatter plot of this data is shown in figure 3.14a. Clearly, the regression relation appears to be curvilinear, so the simple linear regression model does not seem to be appropriate. Okay, so ini scatter plot of Y versus X. We see here a little bit curvilinear here, kan? Ada curve kat sini. So we not fulfill one of the assumption, which is the assumption of linearity. So we cannot use the regression function that we have. Okay, tak boleh nak gunakan that regression function, tak boleh nak buat analysis, tak boleh nak interpret the value of beta, of A, and so on. Okay, so maybe dekat sini, ini linearity yang tak fulfill. Maybe kalau kita check untuk normality dan juga constant variance, it can be fulfilled. The assumption can be fulfilled, but because of one of the assumption is not fulfilled, so kita means that the linear function tadi, our linear regression function tadi is not appropriate because of one of the assumption is not fulfilled. So because of that, kalau kita nak gunakan this data lagi, kena buat transformation. Okay, so because of dia punya pattern ni like this, okay, which is a type A here, so kita boleh try sama ada log atau log X ataupun square root of X. So here, based on the prototype, we shall consider initially the square root of the transformation. So what to do? Tadi kita ada column 1 ni adalah column X. So now, kita create another column ataupun create another variable lah. Create the new variable which is square root of X ataupun X prime kat situ, which is the square root of X. So how to get all this value? Just square rootkan 0.5 dapat this value. Square rootkan 1 dapat all this value. So we will use this value, these two value kan. Kita maksudnya sekarang ni kita ada new X. New X ni dah tak guna lah. Okay. This X will not be considered anymore. Okay, yang ni dah tak guna. Okay, kita gunakan this Y and this new X untuk create the new regression equation ataupun regression function. Okay, so okay, so dia kata kat sini okay, so after we transform the X kepada X square root of X, and then we, okay, here, this is the new scatter plot when we regress Y on square root of X. Okay, dia nampak, we can see the linear relation between Y and square root of X. Okay. Okay, the scatter plot now shows a reasonably linear relation. The variability of the scatter at the different X level is the same as before since we do not make any transformation on Y. So, if we can see, kat sini, kita kena fulfill all the assumptions. So, try buat another plot to check the assumption for the constant variance ataupun homoscedasticity dan juga normality assumption. So, this is the residual plot against the new X kita. So, seems that there is no any pattern here. So, we can say that the homoscedasticity assumption is fulfilled since all the points scattered randomly. Okay, and there is no appear any pattern in this plot. of the residual. Okay. Okay, tengok pula normality plot. Okay, normality plot kat sini seems that most of the point lies along the straight line kat sini. So we can say that the normality assumption is fulfilled. Okay, so that is the way how you do the transformation. So bila kita regress, akan dapat this. Bila regress with the new X transpose tadi, which is the square root of X, this is what we get dia punya the new fitted regression function. So we can use this fitted regression function untuk interpret the value of beta ke, nak check dia punya apa ni, nak forecast the Y, ataupun nak check for the apa ni significance of the model and so on. Okay, so that is one of the cara nak buat transformation. Okay, yang kedua adalah transformation for non-normality and unequal error variance. Okay, non-normality dan unequal error variance tadi kalau tak linear. Sekarang ni kita buat transformation if the normality assumption dan equal error variance assumption ataupun homoscedasticity assumption is not fulfilled. Okay, kalau both of this ataupun salah satu of this assumption is not fulfilled, so kita kena buat transformation on Y. Okay, kena buat transformation on Y. Okay, this transformation on Y may also at the same time help to linearize a curvilinear regression relation. So, kadang-kadang bila normality assumption dan juga homoscedasticity assumption is not fulfilled. So, kalau kita tengok dia punya linearity pun tak fulfill. Okay, bila kita buat transformation on Y, at the same time, it also can help to linearize the curvilinear regression relation bila kita transform on Y. Tapi kalau both of the assumption normality dan juga homoscedasticity is fulfilled, tapi linearity tak fulfill, you kena transform on X. Okay, kalau error variance ataupun constant variance dan normality tak fulfill, barulah you transform on Y. Okay, so macam mana nak transform on Y? Ini adalah contoh-contohnya. Any of the pattern yang you dapat, you just transformkan Y sama ada it can be square root of Y. Kat sini sepatutnya square root. Okay, sama ada you square rootkan the Y value ataupun logkan Y value ataupun 1 over Y value. Any of them. Sometimes kita kena try and error juga. Okay, let's see this example. Okay, we have this data set. So, dia kata kat sini. Okay, the distinct curvilinear regression relationship as well. Okay, in figure 3.16a. Okay, in figure 3.61a, dia ada nampak curvilinear dekat sini. Okay. So, bila linearity not fulfill dan dia tak tunjuk kat sini. So, maybe juga bila kita check homoscedasticity dan juga normality assumption is also not fulfilled. Okay. So, means that dia punya residual versus X having the obviously having the pattern. Okay, which is not scattered randomly around 0. And dia juga, dia punya normality plot, PP plot tu, ada any departure ataupun tail. Okay. And then, ataupun most of the point tu does not lie on the straight line. So, which means that the normality assumption is not fulfilled. So, because of that, kita boleh buat transformation on Y. Sekaligus, ia akan linearizing the curvilinear here. Okay, so what to do kat sini? Dia buat transformation on y, which is dia logkan y. So now we have the new y. So we will use this value of y dan juga the value of x untuk nak create the new fitted regression function. Okay, so dia punya equation yang baru adalah this one. So apa yang you dapat bila kita regresskan log y dan x. So this is the graph that we have where we regress y and x. Okay, mana penerangan dia? Okay, it seems that trykan log y. The transform y values are shown in column 3. Okay, figure contains the scatter. Figure 3.1b contains the scatter plot with this transformation. Note that the transformation not only has led to reasonably linear regression relation, okay, but the variability at the different level of x also have become reasonably constant. So yang ni pun dah jadi linear dan juga these two assumption is also fulfilled. Okay, can you see this residual plot? Daripada sini kita boleh check untuk constant variance. Okay, there shows no any obvious pattern. So the homoscedasticity is fulfilled. And then the normality plot showing that most of the points lies along the straight line here. There is no any tail dekat sini, kan? So we can say that the normality assumption is also fulfilled. So means that we can use this equation. So maksudnya equation ni appropriate for the dataset. Okay, so that is the way how to do the transformation and how to do the how to decide whether you need to transform variable x ataupun variable y. Okay, depends on the which assumption is not fulfilled. Okay, that's all for transformation.